In this video, we're going to talk about analysis of variance or single factor ANOVA, and we're going to use data file insurance survey. So in order to test the equality of means for 3 or more than 3 population groups, we need to perform analysis of variance or ANOVA test. So as you can see here, we are testing to see if the means, population means are equal, but we are actually, at the end of the day, we're performing an analysis of the variance. So why is that? The reason is, I'm trying to explain this in this simplified example. So I'm just gonna focus on panel B here. So if we assume that we are measuring the variance between groups by taking the maximum distance between the center of these distributions. So each graph here, each color, each different color actually belongs to one population groups. So we have 3 population groups here in this example. And then the variance between groups, as I said, if we just take it by the maximum distance between the center of these population groups. So we have it like this, and we have the same thing at panel A. As you can see, variance between groups is smaller in panel A compared to panel B. The second factor that we need to measure is the variance within groups, within each distribution, within each sample. If we find the variance, and again, we have it here and we have it here. So in panel A now, variance within group is much larger than the variance within group in case B, actually, in scenario B. So now in panel A, the variance between groups is much less than variance within group. So when that happens, the groups are pretty much close to each other. The center of the groups are pretty much close to each other, and that doesn't provide us with the enough evidence to go ahead and say that the distributions are significantly different from each other, or at least one of them is different from the other. Whereas in panel B, we see that the variance within group is much less than the variance between groups. And that implies that there is at least one of these groups that is far from the rest, and you cannot assign that variation, the distance between these means, to the variance within groups. So the variation is much longer than the variance within groups. So that center definitely doesn't belong to, cannot belong to the same distribution as the blue one here. So that way we can say actually that there should be a significant variance between groups compared to the variance within group. And that would imply that we may have enough evidence to go ahead and reject the null hypothesis and say that at least one of these means, one of these population groups has a significantly different mean compared to the other groups. So, I mean, in that example that we just saw here, we are making actually the ANOVA is based on multiple assumptions. First of all, as you can see here, we are taking symmetric distribution. So we are assuming that each population has a normal distribution, and also the variance of these population groups, variance of these samples in this case, are equal. I mean, they shouldn't be significant. There shouldn't be a significant difference between the variance of these population. And the third assumption is that they should be all these samples that we're dealing with, they should be taken independently and randomly and independently obtained. They should be normally distributed and they should have equal variances. So if any of these assumptions are violated, then the power of ANOVA can be affected. So that means basically you should go back and double check your assumption. So when it comes to Excel, we need to use ANOVA single factor test, ANOVA single factor tool from data analysis tool pack. And then we just, so one thing that is very important for this one, we need to make sure that the data is displayed in columns that are next to each other. So each variable should be in one separate column and they should be all next to each other. They should be all connected. And then the rest of the process is the same. So ANOVA single factors is an F-type, F test. All right, so it provides us with F test statistic, a test statistic that follows F distribution. But this one, the p-value that it provides, it is a two-tailed p-value, p-value two-tailed. So we don't need to do anything, unlike F test for equality of variance that we had to multiply it by 2. We don't need to do this here, all right? So I'm gonna just go ahead and open the data file. So this is the insurance survey data file, and we want to see if the satisfaction of, let me just go back here. So we want to see if satisfaction, there is any significant difference between satisfaction among individuals with different levels of education. So if I go back to my Excel file, so education is my factor, and it's a single factor ANOVA, right? So education is my factor, and then this factor has multiple categories. So what are the categories? I need to basically, I need to really, there is a pre-processing for this test. I need to have all these satisfactions for each categories in one column. So what I'm gonna do, I'm gonna sort this data file. So I'm gonna filter, I'm gonna maybe select, since I just typed this here, I'm gonna take it back to here, and then I'm gonna click on my data file and filter, and I'm gonna sort it based on education. Let's say A to Z, doesn't really matter. So I have 3 categories. So my factor, the single factor here would be education, but education had 3 categories. So college graduate, graduate degree, and some college. All right, so I have 3 categories. Now, let me just graduate degree. Just gonna change the, all right. So now I know, so satisfaction scores for college graduates, I just copy and pasted it here. Now I do this exactly the same thing for graduate degree, copy, paste, and I do exactly the same thing for some college, copy, paste. They don't have to have the same size. As you can see here, the sizes are, the size of these columns are different, right? That they have different number of, we have different number of students in each group, in each category. Now, I'm just gonna go ahead and in order to check. So let me just write down the null and alternative. So the null is the satisfaction, the average satisfaction score of a college graduate is the same as average satisfaction score of graduate degrees is the same as average satisfaction score of some college. So that's the null, and then alternative would be anything other than that. Anything other than that. I mean, at least one of them should be significantly different from the others for us to go ahead and reject the null hypothesis. All right. So we have done the pre-processing. Now it's time to go ahead and go to Data tab, Data Analysis, and call the ANOVA Single Factor, the first tool in the analysis toolpack. ANOVA Single Factor. And as you can see, that's the reason as why we have to put everything in, every category in one column, because here the input range, it just takes one column. You can't separate the columns with commas, so you just need to put everything at once. And they're grouped by column, so each column would be one category. And then labels in the first row. If you have these tags, you can check labels in the first row. Alpha 5%, that's perfect. Output range, I'm just going to put it at the end here. All right, so when you do that, we just need, I mean, there are a lot of numbers here, but at the end of the day, for the sake of our test, ANOVA test, we just need to take p-value and we just compare it with alpha level of significance. Since p-value is less than alpha, we can go ahead and say, we can go ahead and reject the null hypothesis and basically conclude with 95% confidence that at least one of these groups has a different mean than the others. And when you look here at the averages, we can observe obviously that a graduate degree, people that belong to this group, graduate degree, they have a significantly higher. This is what we see here. And then the variance also is smaller here in this sample. So I can go ahead and say, since p-value is less than alpha 5%, we reject the null hypothesis and conclude with 95% confidence that at least, I mean, we can say this one, or we can say at least one group, one category, one education group, or one category has a different mean. At least one category has a different, statistically different mean, right? So this is what we can go ahead and conclude.